Okay, so this is a first reaction, and then I'm going to look at the second product part, and the CO2 is, you look at that, that's a -2 times 2 -4, and that's a +4. So I write it on the +4. So and then I look at the before and after scenario. As far as the carbons are concerned, is the oxidation number didn't change, right? So this is not a redox reaction. As far as the oxidation chemistry is concerned, there's no change in the oxidation. What about the sodium bicarbonate? And okay, so this one is this is a -6, and sodium is +1. So +1 -6, that makes it +5. So this is +5. I guess this is the same. So I don't see any changes in any oxidation number from left hand to the right hand side. So this is not redox reaction. Right? So you're just looking at the bookkeeping. Later you will actually keep the stoichiometric balances and so on. This is another practices. But given that somebody gives the equation, I can figure that out whether this is a redox reaction or not. So let's look at the second one. It's the second one. So this is a potassium, chlorine O-. So potassium, like cesium or sodium, want to be K+. Oxygen want to be -2, the -6. So therefore chlorine must be +5. Okay? That's the oxidation number. And for this compound, H+, oxygen 4-. So this one is 3+. So this is an oxidation number for the compound on the left on each of the elements. And then if I look at the product side, this is a plus, this is a minus. Chlorine wise, chlorine became -1. And then this one is +1, -6. So that's a +5. So this is one. So now you look at the oxidation number. These are the numbers are all oxidation number. So this is an oxidation number goes down, right? And this is an oxidation number goes up. So which one is reduction reaction? This is I want to make sure I'm being clear. This compound is being reduced. Right? I'm using the passive form. This is a being itself is being oxidized. All right. So if this compound, nitrogen-containing compound, which is up here, if this one is being oxidized, I'm being oxidized at the expenses of somebody making what? Reduced, right? So I'm making something reduced. So this one is because I'm being oxidized. This is we call reducing agent. Does it make sense? Do you remember the oxidizing agent and reducing agent? Reducing agent is you make something reduced. To do that, the agent itself has to be oxidized, right? What about oxidizing agent? The oxidizing agent, this agent makes something oxidized. Therefore, the agent itself has to be reduced. So if it's being oxidized, this one means, this is just the terminology that you have to just get understanding. So being oxidized means this is a reducing agent. Being reduced means oxidizing. Okay? So this compound is oxidizing agent. And the other one is obviously the other one, which is a reducing agent. So this is being reduced, and they're oxidized. Something that is reducing is an oxidizing agent. Being oxidized is something is a reducing agent. And this reaction is a redox reaction.